Hi, everyone. Thanks for the introduction, Kevin. Yeah, this talk's going to be about using a relatively new feature of Dart called Dart FFI and how to use that inside of Flutter. So I'm Richard Heap. I'm a co-founder of Software Hothouse and Just Speak. Software Hothouse is a company that's been developing voice recording applications for nearly 20 years. And we've been using Dart for over 5. So our applications record voice conversations, typically call center conversations, and then allow you to play those back later. And if you were using Chrome as your browser of choice to play the recordings, then for the last 5 years, it's actually been running Dart in the browser, compiled into JavaScript. And in order to achieve that, we took all of our audio codecs and audio processing modules and ported them into Dart and compiled them into JavaScript using Dart2JS and ran those in the Chrome browser. So when about 2 years ago, Flutter started hitting the mainstream, it was great for us because it meant that we could use a whole bunch of our existing modules, and we could they would just run directly in mobile for us by compiling the Dart code in mobile. So then it's sort of interesting because when Dart FFI became available, which is the ability to call C routines, most of these audio applications that we were doing were actually started originally in C, and we'd ported them from C into Dart. So with the advent of FFI, we were able to actually go back to just calling the majority of those audio routines directly from Dart into C. So what is FFI? FFI stands for Foreign Function Interface. It's a mechanism by which one program, or a program written in one language, can call routines written in another. So in FFI, there's a concept of a host language and a guest language. And for us, Dart is the host language, and C and C++ are the guest language. And you can do this in standalone Dart, just if you're using Dart in the back end, or just the plain Dart SDK. There you'll be talking down into a shared or dynamic library. When you come to Flutter, there's actually a couple of variations of that. You can actually have the Flutter toolchain build the C and C++ for you. And that's actually what we'll be looking at today. One thing of note is, even though I started talking about how we used Dart in Chrome originally, you can't use FFI in Flutter Web because there's no way to compile the C and C++. So it only works in the ahead of time compiled code for example, Android, iOS, and Mac OS on desktop. What we're going to look at today is two separate projects, two separate pieces of audio processing. The first one is what's called a resampler. So when we're dealing with speech, it's normally encoded at either 8 or 16 kilohertz sample rate. And sound cards in PCs and mobile devices typically work at 44 or 48 kilohertz. And we need some way to convert between the two. And that's called a resampler. And many years ago, I took a C resampler and converted it to Dart and I went back and I took the same resampler, wrapped it in FFI, and produced a Flutter plugin with exactly the same code. And it's pretty much plug compatible to my Dart package. And I've put that up on GitHub, and you can, you'll be able to, I'll give you the link to that at the end. The other thing is, if you want to use the really low latency audio in Android, you have to go down into the NDK, and the NDK is written in C. So normally the way to get to that is that you use the Java JNI bridge to get from Java down into the NDK. And if you're then in a Flutter application, you've got to go from Dart to Java using a method channel, and then Java to C to the NDK using JNI bridge. And I wondered whether it would be possible to go directly from Dart down into the NDK. And so we're actually going to try coding that later on. So a typical audio chain that we would have built in Dart in the browser starts off with an audio source, something like a jitter buffer, then an audio codec decompressing the audio. Again, most of these are written in C, and so we've been able to switch back from porting them to Dart to just calling them directly in C. The third box there is the resampler. That's the one that I've made available on GitHub as an example code. And we're going to concentrate on this fourth one. Can we find a way to interface directly to the NDK to deliver audio to the sound card? The way FFI is implemented in Flutter is by using a type of Flutter package called a plugin. And Faisal yesterday talked about pub.dev and how you can find really useful packages and plugins up on pub.dev. There's a whole slew of plugins for things like shared preferences. There are packages for encryption. There's pretty much everything that you could want. And the difference between a package and a plugin is a package is just entirely Dart. So it's code that's been ported into Dart. And a plugin is something that needs to talk down into the Flutter native code. So it's got some combination of Java or Kotlin and Objective-C and Swift code bundled with the Dart code inside of that package. So when you add it to your dependencies and you do your Flutter pub get, you're not only getting the Dart code down to be included in the Dart part of your Flutter app, but you're also getting a little package of Java and C code or Objective-C or Swift code that gets compiled by the toolchain at compilation time. The other nice thing about a plugin is you get a little Flutter example app that's provided for you by the author of the plugin. And that's useful to see how you should be using the plugin. It allows you to exercise the plugin. It's kind of useful. When you're developing plugins, you've got to use Xcode to edit the iOS parts, the Objective-C or Swift. You have to use Android Studio for the Android, Java, or Kotlin. And my recommendation is to use something else for the Dart code. So I'm going to use IntelliJ. You could equally use Visual Studio Code. And there's something about having those three, that separation of the code into the three IDEs is very, very useful. So what's the difference between a FFI plugin and a regular Flutter plugin? FFI plugin just has the Dart code and the C and C++ code. It's missing the Kotlin and Swift code. Actually, I think you can include those as well if you needed to form some sort of hybrid. So now you've got a choice. You can use Xcode or Android Studio for the C. And again, I would stick with something else for the Dart. Sadly, when developing plugins, there's no hot reload. So hot reload works in Flutter by injecting a new copy of the Dart source code into the side of the running VM. Obviously, there's no way to change the Swift code or the C code or the Java code in the same way. And so there's a lot of waiting for Gradle to build. I like to put this this diagram up, next slide, because it shows the threading model that's going on inside of Flutter. So your code that you're writing when you're creating stateful widgets, stateless widgets, writing build functions, etc., is running on this thread in light blue that's marked as the Dart UI thread. And that's running inside the Dart VM. And when you want to call to native, for example, to do shared preferences, what's going to happen is that code, the native code, is going to run on this left-hand thread called the platform thread. And to get from the Dart UI thread to the platform thread, it's almost like a remote procedure call. The method channel marshals the method call and the parameters, drops them over to the platform thread, which unmarshals it, executes the method, marshals the result, and drops it back over to the Dart UI thread. So if you've ever used plugins in Flutter, you'll know that there's a lot of async await wrapped around anything. You know, the standard question is why do I have to await shared preferences.get instance? And that's because it could result in a call from the Dart UI thread to the platform thread. The interesting thing is, if we're going to use FFI, we're not actually going to leave the Dart UI thread. We're just going to be calling directly from Dart down into C and then back up. And so we won't be leaving the Dart UI thread. So in fact, most of the C methods that we're going to call are not going to be async. We're not going to have to await for them. Next slide. So creating a plugin that you're going to use for FFI is pretty much exactly the same as creating a regular Flutter plugin. Starts off with the Flutter create command, -t, the template is plugin, your organization, Android X, and then the name, the plugin. And one thing that's kind of important when you create a plugin is to immediately run it before you try opening it in the IDE. And there's a reason for that. It's when the first time that you run when you run the example app that's part of the plugin, there's going to be quite a lot of code gets generated. All the little generated registrants all get created, and on iOS the pod gets installed. So we're actually, in a plugin, you're actually developing a pod, and that pod has got to get installed into the app. So then you'll want to, once you've run it once, you can just run it up, close it again, then you can open it in Xcode, and now you'll actually find that it can find the source code because the pod has properly been installed. So how do you go about actually writing your first C function? Here's a really simple one. Okay, this is the signature of a function called sum that takes two parameters, A and B, both of which are 32-bit signed ints, and returns a 32-bit signed int. In fact, I think this one is actually in the in the wiki of how to start using FFI. And up at the beginning, I've included the standard int header. It's an important header to use because it declares these precisely sized integer types. So int 32, int 16, uint 16. If you've used C in the past, you may remember that sometimes things were called short, some were called long, some were called int, and you could never quite be sure on any one platform which integer size you were using. So standard int gives you precise integer sizes. The other thing about FFI is that it's definitely a C-based interface. So if we're in C++, we need to define extern C as extern C. And then we annotate all of our methods with extern C so that they don't get mangled. The naming doesn't get mangled by the compiler. Now comes the tricky bit. We got to go into Dart and we got to hook up that function, that method. So we start doing that by writing a pair of type defs up at the top. And you'll see they look similar but different. So the first one with the capital int32 is the type def that describes the C function. So it's a function that takes two parameters, A and B, both of which were int32s, and returns an int32. The second variant of it has got the lowercase int, and that's the Dart style type def. So Dart doesn't have different sized of integers. In Dart, all integers are signed 64-bit ints. So by writing this pair of type defs, what you're doing is telling FFI what the signature of the C function is like, and then how that's going to be exposed to Dart as a Dart type def. So we've written our two type defs. Now we need to get hold of a reference to the C code. And this varies very slightly depending on the tool chain that we're using. So in the Android world, the Android toolchain builds your native code, your C code, as a shared object. So it's going to be lib something.so. And so we're going to use dynamic library.open for that. The Xcode toolchain actually compiles your C code directly into the main executable. And so there we just use this slight variant called dynamic library.process. And that means get me they're in process. Just give me the handle to the current process. Okay, so we've got two of the three parts necessary to call our function now, which is we've got our two type defs, a reference to the dynamic library that the method is in. And now last thing we need to do is to look up in that dynamic library the actual method. And that's done by this lookup method. So we're looking up a method that's a native function that has the signature of the first type def, of the C style type def, called sum, and we're casting that as a function to the Dart style type def. And actually we then just store that into a local instance variable. And actually now it's remarkably easy to then use that method. So you can see here, I've got this text widget, and all it's got in there is 1 + 2 equals. And now we can just use the singleton constructor followed by .native add 1, 2. So we've seen a little bit about the types of int that were allowed. What other data types can you get across from Dart to C? Well, remarkably enough, not bool. If you've got a Dart bool, you're going to have to convert it into a 1 or a 0 or something like that to send it to to C. The Dart int, remember that's a 64-bit signed int. Then in C, you can convert that into either a signed or an unsigned 8, 16, 32 or signed 64-bit int, not unsigned, won't fit. Floats and doubles become floats and doubles. A Dart string becomes an array of UTF-8 chars on the C side. You can have pointers. So if you've got like an array of floats in C, or array of floats, then the reference on the Dart side to that is going to be a pointer to float. And you can allocate and free memory either in Dart or in C. Typed data, if you've used like uint8 list and things like that in Dart, then those are just arrays of ints, floats, and doubles. And you can turn from this pointer type into a typed data. You can't turn it the other way around, slightly frustratingly. So the first piece of sample code is up in GitHub, and I took this library called libresample, and it's the one that we had used before, converted into Dart, and I wrapped it inside this, wrapped it inside a Flutter plugin, and using FFI, and put that up in the GitHub. Interesting news coming up about FFI is there's a Google Summer of Code project slated for this summer. And the idea of that is to see if you can generate these FFI bindings, that's the pair of type defs, directly from the header files. It'll be very interesting to see if that comes up with something useful. I think it'll work great for modern C and C++, but for the some of the libraries I've tried to wrap are older. They aren't using standard int, and so I end up having to write a shim layer in between the two to convert, to basically be sure that I'm getting the right integer sizes. So what's Android Oboe? Android Oboe is Google's new audio library, part of the NDK, that allows you to write low latency audio. And I thought it would be fun to see if in the 15 minutes that we have left, maybe 20 if we cut into the questions, whether we could actually wrap Oboe in FFI and see if we could actually talk directly from Dart down into the NDK. So dash meet Oboe. Okay, so I hope you're seeing that. Yes, looks good. Following the excellent instructions on the Oboe website, it starts off by saying git clone Oboe. And actually, there's some really useful YouTube videos by Don Turner of Google, who's really into audio and is one of the authors of Oboe. So I've already done this git clone, so I should now just be able to create my Flutter create -t plugin, and I'm going to call it Oboe FFI1. And as it says here at the end, it says right now you should cd to Oboe FFI1 / example, and then do Flutter run. And what you will find is that you get the stock plugin, the stock plugin template comes up and it tells you which version of Android you're running on, or iOS if you're running on iOS. And right, so let's go to Android Studio. And what I did was I already created Oboe FFI 2 because I've already done that run in there to save a couple of minutes of building. Now, when you open a Flutter plugin, it's a little odd. Don't go and open this top folder here. Drill down a little bit further into example and then into Android and open that folder. And what happens now is that you see that we've got two parts to the app. We've got the top bit is the example app, and the bottom half is the actual plugin. So we're not going to be changing the example app. So even though we open the example app, it's given us access to the innards of the plugin. So we need to enable C and C++ in here, which we're going to do by going to project non-source files, opening that source. Right, so the first thing we need to do is to go and change our build Gradle here. And let me get what we need to do is to add this little fragment of code down here. So that's going to tell the Gradle that we've got an external native build and it's going to be in a CMake. We're going to be using CMake for that. So we just add that in there. Of course, we now need to go and create that file. So we're just going to create a new file. We're going to call that CMake lists.txt. And in that CMake file, we are going to, first of all, add the stuff that the Oboe website tells us to add. It's just a bunch of stuff for Oboe. And then we're going to go and add this minimum requirement for our CMake, and we're going to have to go and put in some source code. Okay, so we're going to create source main CPP, and then we can call it anything we like, Oboe FFI export.cpp. And I suppose we should then go and actually create under source main. We've said that we're going to have a new directory called CPP. And in that CPP folder, we're going to have a new C source file. And what did I call it? I called it Oboe FFI export.cpp. Okay. And it's complaining that it's not part of the code, but if we were to do a Gradle sync, it might configure it for us. So let's see if it does. And now if we go to project source files, fantastic. It's appeared as one of our source files. So our CMake is now nicely highlighted, telling us that that's ready to go. Our build Gradle is got our external CMake in. We didn't seem to get any errors from that. So that's fantastic. The other thing that you can see is that it's actually given me access to the whole of the oboe source code should I want to drill down and see anything important down in there, or I just want to see a little bit more about how oboe is implemented. So now oboe tends to think about things as like streams. So I think first thing we should do is to probably create a C class, and I've called it oboe FFI stream. So we've created ourselves a C class, because what's going to happen is we're going to ask oboe for a reference to a stream, and we're going to have to wrap that in, hold that in something. So let's hold it in this oboe FFI stream. And because we're going to be wanting to use oboe in here, I guess we should. Okay, maybe we need to build. Oh, you know what I haven't done? I haven't told CMake that this file is part of our source code. So we need to go source main cpp oboe FFI stream. And we go back to here, it's going to say we need to do another Gradle sync. And bingo, we've got rid of that red. So kind of things that we're going to want to do with an oboe audio stream are to maybe construct one and maybe ask it what its native sample rate is, because you remember if I was talking about resamplers before, we want to know what the sound card's sample rate is. So we need to create those. So that's how we're going to get the sample rate. And in fact, actually, we need to get that constructor. So let's put that constructor in. So what we're going to do in the constructor is oboe uses a builder pattern to build its streams. So we use an audio stream builder, and on the audio stream builder, you can set the format, the channel count. So we're just telling it that we want to be able to use floats. I only want a single channel. I don't want stereo. You can ask for certain guarantees of latency, all sorts of things in there. And then we're going to use that builder to open the managed stream, and we're going to give it a reference to a managed stream. So let's go and save that managed stream somewhere. And this is the reference that we're going to want to hold on to, so that having created our managed stream, it doesn't go away. So we've got our C++ class here that knows how to use oboe's stream builder to open a stream and get it. And so let's create some let's actually just take the whole of that up there and put this in. So remember this file that we created that's going to expose all of our methods. So this is, you saw this before, the if-def extern C, and then we need to create some C style methods. So one of them is going to be create, one of them is going to be dispose, and one of them is going to be able to get the sample rate. And you see that when we create a stream, we're just going to return a new stream as a pointer to void. And then when we dispose of that stream, we're going to take that pointer to void back again from Dart and cast it back into the stream so that we can then close it and delete the stream. And when we need to get the sample rate, we're just going to cast the pointer to get this and then call the get sample rate method. Looks like I need to go and would be a good idea if I implemented close. by the looks of it. So over here in close, we've got the sample rate, and we're going to want to have that in the header as well. Okay, so we can now open an audio stream, we can dispose of the audio stream, and we can get its sample rate. And those are the three things that we've got over here. So let's go to IntelliJ and open the same project in IntelliJ. So this is how this is the single piece of code that the template created for you. Well, actually, it created two. So it created this little piece of stump code, which is the one that's calling the get platform version, which is what over here was showing us the running on Android 10. And then it's created this sample application that, as we see, has got the text running on Android 10. So what we need to do here is to do that type def stuff that I was talking about before, which I'm going to do. Oh, hang on. What we need to do is, so there's my type defs for all of these, and FFI. Let's import Dart FFI so that now it understands these pointers. So here you can see that we've got a function with no parameters returning a pointer to void. And then these other functions take a pointer to void to dispose it. And then when we want to call a sample rate, when we want to ask the stream for its sample rate, we pass back the pointer to void, and we're going to get an int32 back or a Dart int. So what I'm actually going to do is to just switch to this one, which has got the rest of it filled in. So you can see here I've commented out the code that was provided for me, and I've turned this class into a singleton by giving it a static instance, a public constructor, and a hidden named constructor. And I've created these excuse me, I've created these member variables, which are each of the functions that I've looked up. And here, down here, I've opened the dynamic library, and then I've looked up each of those C functions and stored it in my Dart function reference. Now, I find it's very rare that you ever actually want to allow your platform users to have access to these, which is why I've marked all of these as private with the underscore at the start. But what I've done is create a public stream, which is oboe stream, and it's going to wrap the plugin's private methods. So you can see, for example, that when you construct an oboe stream, it goes and calls that C function to initialize the stream and retains that pointer to void as my native instance here. When you call dispose on it, it's going to call dispose, passing back the native instance. When you call get sample rate, it's going to call this stream sample rate method, again passing in the native instance. You can see here I've created start and stop as well, which are two other oboe methods to start the stream and stop the stream. And lastly, I've taken a oboe method which is to write to the stream, where we're going to pass it actual floats that we want it to render out to the sound card. And here I'm taking, remember I said you can take the type def, typed data coming in here. And what we're doing here is allocating a array of floats, a C array of floats, and then casting that to a typed list so that we can set all of the values in it, sending that copy of the array of floats down through the C interface, and then freeing that when we're done. So if I stop this and hit run up here. Oh, the other thing I should do is to show you what I did in, I don't need PubSpec. In main, there's no async anymore. Okay, so I've just got my stateful widget here, the state of the stateful widget. I can immediately make the oboe stream. I don't need to wait for it because it's going to be synchronous creating it. Going to create a, actually I started off with white noise. I've changed that to a sine wave. So I'm using the sine function to create a sine wave, so it should create a single tone. You notice how I've overridden dispose in the stateful widget, so that when dispose is called, it's going to dispose of the stream up here, so that we don't get so that the actual C delete function gets called to dispose the stream. And then I've added some a start button and a stop button, printed out the sample rate, and in the start method and the stop method, we're going to start the stream, stop the stream, and in the start method, create a periodic timer to actually write the sine wave out every however many milliseconds. It's going to send another 512 bytes, 512 floats worth of audio out to the sound card. Now I'm going to turn the microphone round and point it at the screen, and hopefully I've got the sound from the emulator coming out through the screen speakers, and then it'll be picked up by my microphone, and you may or may not be able to hear it. Oh, okay, that's interesting. So we've got some debugging coming out here from Oboe Audio. It's gone. Well, we are running on Android 10, so not surprisingly, it's gone for the A audio under the hood. It's told us what the sample rate is. It set up various internal buffers, and if we're lucky, I've got my volume turned down too low. Hold on. Turn that right up. Let's turn the volume up on the here. I hope you can just about hear that. Maybe if I hold the microphone a bit closer as well. We have just managed from Flutter using FFI to talk directly down to the A audio library in the NDK using the Oboe wrapper around it. And so I'm going to stop that. Oh, somebody says you can hear it. Great. Let's move this to here. All right, so let's go back to here, present, page down, and thank you. We've got just time to do any questions. Oh, I see something's just rolled off the bottom of the screen there. I said, if you want to ask questions about FFI on Stack Overflow, there is a tag. It's Dart-FFI. Dart-FFI is the tag for Stack Overflow questions about FFI. The first question is, how are the performance compared to a full Dart package? Well, I can tell you that like some of our intensive audio codecs that we do are 2 or 3 times faster calling down into C rather than using the Dart native code. The biggest limitation of FFI currently, okay, I can think of 2 off the top of my head. One is that you can't pass C structs across FFI. So if you wanted to, if you were wrapping a library that required you to fill in some sort of C structure and then pass that across and then call initialize on that, then you can't do that. You've got to go and pass your, you got to go and pretty much actually do something similar to what method channel does, which is to marshal all of the bits into something and then copy it across and then unmarshal it at the other end. The other big limitation is, and this is something that is kind of relevant to the oboe demonstration there, was you can't call from C into Dart. So the normal way that you talk to, that you deliver audio to oboe is that you pass it a callback and it calls you back on its thread. So actually, when we did this for real, what we did was we just used a circular buffer, and we would feed into the circular buffer from the Dart side and then have the oboe callback collect data from that circular buffer. So those are the 2 big limitations I can think of: no passing of structs and no calling back. Yes, we use Flutter in production in various different audio applications. Can you use oboe and FFI to create an audio player with visualizing the audio sound? Yes, yeah, absolutely. So oboe is just a wrapper on top of audio, which is the NDK library, and also OpenSLES for the older versions of Android, all the way back to Jelly Bean. So oboe has a very audio-like API, and it then emulates audio using OpenSLES on older versions of pre-Android OMR1, I think. How can I pass an image to my C++ program from Dart? Which data type shall I use? Okay. Actually, there is a Flutter plugin called Bitmap that you should go and look at. And can't remember the author, but they used FFI in that, and you can do things like change the luminosity of the image and things like that. So I'm, depends on what your C++ program is going to want to do with the image. Is it going to want to have it as a bitmap, or can you just give it a PNG and have the C++ decode it? Either way around, you're essentially going to be passing an array of bytes across, yeah, pass an array of bytes as a uint 8 list or a pointer to uint 8. Will this work in any language which can be spoken to via FFI, such as Rust? No. So the host language, go back to that like third slide. There's the host language and the guest language. The only guest language that's supported is C and C++. And that's partly because, particularly in Flutter, the way the toolchain works. New to field of programming, how is the simulation of the mobile device made? Okay, so that's just the Android emulator. When you install Android Studio, you should install the Android emulator, download the SDK, download the emulator, install it, and you can then run on a variety of devices like a Pixel 2, Pixel 3, various different emulations. Equally, if you've got a physical Android device, plug it in via USB and you can run on that as well. How to use external C++ libraries? Okay, do I need to add some other dependencies? The dependencies of yeah, so you saw in the CMake how it was that I just followed the instructions from the Obo website of how to depend on that. It should be exactly the same. Android Studio is supporting lots of languages, Java, Kotlin, Dart. Why do you say to use something else for Dart? I missed something here. No, you didn't miss anything. It's just that if you there's something about opening because in a plugin project, you get the sample app and you also get the plugin part. There's something about opening the sample app and the plugin part in the same instance of Android Studio really messes things up. So my experience has been I've managed to brick my project so many times by doing that by mistake that I just say, especially for beginners, use a different IDE for the example project than you're using for the Android Studio code. Did you try to bind external build C++ libraries into a Flutter application? Externally, yes, I have. The instructions on the Flutter website are terse to the point of being cryptic about this. I have done it, I think, for an iOS framework library. And I've also done it talking down, as actually we just saw there, talking down to A audio on Android. What I have had less success in doing is to like pre-build an Android shared object and include that into my project. So I've luckily never had the necessity to do anything more than just include the source code into my project. Can Python be called from Flutter? No, don't believe so. Are you aware of OpenCV? Would it be possible to have Dart wrapper to the OpenCV implementation? How can we interact with customs? Okay, yes. So the issue with structs is the same issue that I alluded to before, which is the problem of that at the moment you can't pass a struct across. So what you actually have to do is to pass each of the component parts across and then copy them into the struct or marshal it in some other way across the boundary. That looks like the last question.
Thank you, Richard.